Hi, this is Dermot Kerin with Qnect, and want to welcome you to our webinar today. Qnect was founded in 2014 and received investment funding led by Nucor in April 2018. Qnect team has over 80 years of experience in the steel industry. Our technically integrated solution provides automated and optimized connection design perfect for getting early data and delivering fast, cost-effective engineering connections. The seminar will be given by the gentleman shown in the middle, Henry Lederman. Henry?
Thank you, Dermot. The left is Jeff Sharp, our CEO, and this is Jeff Hauster, our Chief Operating and Technical Officer. So here, let's start the technical presentation, and we're going to cover two areas that are very powerful in helping minimize schedule drift. The first one has to do with the extraordinary speed of our software that will provide weeks and weeks, if not months, depending on the size of the project, of buffer time that will help facilitate changes that will happen. The second part of our software and presentation's power is the speed in making revisions. Obviously, there will be a great deal of revisions on every job, and our software is extraordinarily fast for that purpose and includes connection engineering. As you know, conventional systems require a connection engineer and a detailer. We still need both, but Qnect will integrate those. So why do changes happen? Well, obviously there are many changes, and I certainly probably don't need to tell you what they are, but let's just kind of do a synopsis of how it could happen. An owner has a building, they're trying to secure a tenant, they move the process back, they're anticipating a tenant a certain date, therefore we move the erection date, drawings for approval date, and therefore the design drawings need to be released by a certain date. Often negotiations start, people commit to dates, the tenant is not secured, the award drifts, and even as the award drifts and the tenant is secured, you're often asked to produce based on the original schedule. So design drawings are often released because of this backing up of time relative to tenant, and they're often released before they're complete. There are other areas, so obviously design changes, conflicts on designs, coordination changes for other trades, RFIs, RFI design changes, approval design changes, email requests, and material substitution. So all of this starts to happen and occur during the detailing production, which ultimately leads to a drift in the date for drawings for approval, which then leads to drift for the drawings to the shop, which ends up leading to a collision of competing resources when one drift leads into the production of another job, and we often see chaos and scramble. Let's now move to the first part, but the first thing I want to do is a quick refresher of how Qnect works. This will be very, very quick. We're currently on the Qnect website. We have a job called the demo building, and on this website, on our Qnect website, we will prepare, set up, introduce all of the parameters for both the design and the detailing of each joint. Each joint is custom designed, and a custom component Tekla component is produced. Once this is all filled out with our support, then we're ready to have this information follow the connection engineering and the modeling from day one all the way through revisions. And of course, including estimating, where our software is often used in support of the bidding process. Once you've signed up with Qnect and you open your Tekla model, which we're on currently, our buttons Q1, 2, 3 will show up. And the process is the same whether you're doing one joint, one floor, one phase, or the entire building. To do this, this is already Qnected building. We connected about 201 joints, and we would have selected the whole building, hit button number 1. Then we would get an email that said it's done. We'd hit button 2, and this information would be populated back into the model. So let's at least do one joint because it will take about a second. We select these members. We hit button 1. And this comes up. We sign in. We find a company. We find a job. And we will call this session Web 1. We submit. Again, we don't have to wait for an email because with one joint, it is extraordinarily fast. And we see that it's already there. We submit, and it's complete. All right, so that's the process. And as you can see, this uses the 3-inch standard spacing. And so let's just show you very quickly what happens when we optimize a joint to give you the dual opportunity for speed and savings. So there are about 6 folds. We'll delete this connection. We will go to the website and activate the optimization. We'll submit back to the model. Once that's activated, again, we'll select both members. We hit button 1. We'll give it a session name. We submit. We know it doesn't take very long. We hit button 2. And it's not ready yet, so it's taking just a tiny bit longer. We'll hit button 2 again. And now it's ready, as you can see, and we submit. And we see for the very same reaction, this connection is now reduced by 2 volts or 33 1/3%. So this is the process. Whether you want to use optimization or not, it's button 1, button 2, and the whole model is done, or 60 to 80%, and then the connection is fully engineered. Now let me show you real quick. Here's the first output, just the bolt size, angle size, general data. Then we'll show you the strength, which is the output limit states, all the limit states. And then if we click on the code, we'll see all the calculations, EISC references, etc. So you've now seen the speed, the modeling, and the engineering. So let's just sort of now look at how the speed creates the buffer of time. And you may want to jot down just for yourself, because you're going to be the one to determine it. How long would this model have taken you for connection engineering, and then for a detailer to model the connections in, no matter how fast they are and how well they use Tekla macros? We all know that detailers are really pretty smart and fast with it. But the whole process between waiting for connection engineering, detailer interpreting the chart, creating the macros, putting it in, and then the detailer checker checking to see that that was done completely. Just write down for yourself how long that would have taken. And now that you've done that, let's just note that this is about a 50-ton project. We connected 87%, and this 87% of connections, these 201 connections, took 1 minute and 20 seconds. So if you reduce 1 minute and 20 seconds from whatever you wrote down, whether it's 2 days, 1 week, 1 day, that's the buffer we created on this model. Let's go take a look at a couple others. And just bear with us as these models get populated into the Tekla software so that you can do your analysis again. So here is another model where we Qnected it. We Qnected about 66% of the joints. Another, it's a nice job. It's about 200 tons. And I'd like you now to write down how long it would have taken, not just to model it, but the process between the connection engineer and the detailer that ultimately results in all of these connections being placed in the model. All right. And now that you have completed your math on that, I can report to you that we Qnected around 66% of this particular building, over 400 joints, and we did it in less than 10 minutes. And now let's go to, I'm going to show you two more. Let's see, a village. Okay, that's fine. Let's do that one. And again, just bear with us as the model gets populated. We felt it was important that you see actual models of different sizes, so you can really start to appreciate for yourself how the buffer could get created. So we see connections. Actually, this one, it's a very clunky building, very odd shape. I think we've got some moments in here. Here we go. You can see a Qnected moment connection there. There you go. So we've got quite a few connections on this one as well. Some more moment connections. We also do full pen weld. So, so this model, this one is 430 tons. We connected 53%. For different reasons that we could investigate. And often our first run is not where we stop, because then we go back in and we can increase the count, sometimes 5 to 10% once we understand why it didn't connect. So please write down again how long you think this would have taken you. Again, connection engineering, waiting for that, and so forth. So we connected about 53% of these connections, and this one also took us less than 10 minutes. And the last one I want to show you is a little bit of a larger project. This one is a project that is currently being negotiated. It's still in bid. So it's a pretty fresh project that people are competing for, and just bear with us, if you will, as this one gets brought in. It's, let's see, it's about, I think it's a little over close to 9,000 tons. And so we start to zero in on the connections. This one is not super complicated, but lots and lots of connections. There are many things complicated about it for sure, but Qnect is able to run through this pretty quickly. So make note and write down for yourself what you think this will take for connection engineering and detailing back into the model. Now that you've done that, I can tell you that we're connected around close to 6,000 joints, a little over 60%. And this entire process, once we had filled out the parameters on the website, took 2 hours. So if you remove 2 hours from your amount that you have stated it will take, there is your buffer. We did a 30,000 ton, 60-story building, 15,000 connections in about 3 hours. So there is no question, not because we said so, but because our users have reported back, we will save weeks. And on one job, we are saving 19.2 weeks. This is a, let's see, what's that job? It's, trying to remember now what it was, but it's a, oh yeah, it's a pretty big job. I can't say what it is, but we generally see time savings of 20 to 30% of the detailing time. And so if you think about whatever the detailing time is that you're expecting on a job, if on the low end you took 20%, so if it's 15 weeks, you're going to save 3 weeks, and there we start to create the buffer. So that really is the extent of what we wanted to present in terms of the first part. And now we'd like to turn this over to Islam Radwan, who's our another one of our technical members. And he's going to show you now, he's going to actually make a revision with the combination that you just saw with the one joint of connection engineering and detailing, because the speed of the software is extraordinarily important on the second major area that derails and causes schedule drift, revisions. We talked about that earlier, revisions from numerous sources, coordination, late mechanical. And so you can't get away from that, but you can't mitigate it. You can't help the schedule drift. So with that, Islam, please take over.
Hello, thank you, Henry. Now I'm going to change, do a revision in the model and show you how Qnect can handle revisions quickly. So I'll switch to the floor plan here. And in this area, we're going to have to do a change. So first we'll delete the connections. And then I'm going to move this beam. And this beam also will make it skewed. I'll add another beam here and then change some of the loads for another one. Let's make this 20.
And let's also change the beam size, Islam, would be good for the users to see.
Okay. And this beam size as well.
Okay.
Then we'll select this whole area and then we'll do Qnect bottom 2 and export. Bottom 1 and export. I'll just 0.1.
Yeah, we can also use a RFI number or the bulletin number, and that's fine how you have it, and because that is also tracked on a report.
Okay, and then we'll now upload the changes. So doing this revision manually is time consuming, and also you may need to check with the connection design engineer for each one, but with Qnect you can get all the connections fully designed and engineered in a matter of a minute. So we'll try now and see. So those are done. We're going to import. So, and the connections now are added and the revision is made. Switch to 3D as well to see.
All right, thank you, Islam.
So that's how
And
Qnect handle revisions very quickly by just changing the model and re-uploading the connections to the Qnect website, and then the connection will get engineered in a matter of a minute.
So thank you, Islam. And as just to repeat, there are two ways that you can mitigate schedule drift. The first one is thanks to the extraordinary speed. We combine the connection engineering with the modeling back into the model. And the time that it takes to do it in the conventional manner creates the buffer, because no matter the size of the job, we can have it done within hours. And second is the speed at which revisions are produced, and certainly aided by the fact that we're also engineering it at the same time, so there is little to no coordination with the connection engineer. That concludes our part of the presentation. I'd like to turn it back over to Dermot to take any questions that you may have. And then at the end of this demo, we're going to ask you to please just fill out another survey. Thank you very much.
Yes, so the first question that came through is, can Qnect help get shop drawings back faster?
All right, well, thank you, and thank you everyone for being on the webinar. So if the questioner is asking about approval returns, the answer is actually yes. We are having quite the impact on the approval review process, because Qnect puts the loads, the code, the connection capacity, utility ratio back into the model. And by creating the shop drawing template, that information is showing up directly on the shop drawings, identified as the left end, right end, capacity, reaction. And engineer of records are really appreciating this data, which tells them that they don't have to look at the end connection if they see our code on it. And users are reporting a quicker approval return with less back and forth with the EOR.
Thank you for that question. The second question that came in is, can you optimize while saving time? Does optimization slow down the speed of Qnect?
Well, it doesn't. It doesn't slow it down. They're both done. The time and the optimization is done simultaneously. The fact is that we have expansive and expanding computer power with our Amazon Web Servers. And so while there are thousands, hundreds of thousands of calculations being done, it's not an issue at all.
Thank you. The next question that came in was, when there are design changes, how can Qnect help?
Well, I think you already saw that in the second stage of creating buffers for schedule drift or even improving schedule. There's no revision that if you take any particular floor and you change all the beams and change loads, all of that, we're likely to be able to engineer and detail back into the model all of a floor in 10 minutes. So the speed is extraordinary, and it's the second way we help buffer schedule drift.
Thank you, Henry. And the next question that we have in is, who do you propose, or who do you see using Qnect software most often, engineers or detailers?
Well, we're seeing quite a mixed bag. First, I'll add that general contractors certainly like what we're doing, and in particular, they deeply appreciate the schedule impact. when the buffers that we provide are used in that way. Fabricators are certainly a big source of the use of our software. Engineer of records are also using our software in some cases for delivering connected models, and that's also growing. And then, yes, of course, detailers. So as it turns out, we know we cover the ability for several people to use it for all the processes.
Thank you, Henry. And the most recent question that just came in asks, how are the connections calculated?
Well, the connections are all designed to meet AISC requirements of 14th edition and covers all of the limit states that you would expect, demand, and require that the EOR would require. I would add that we've done numerous jobs across the country, and every time we do a job, if it's a new connection engineer, because we have connection engineering partners that work with us, we also have detailing partners that work with us, but all the connection engineering partners have had to validate the engineering for the first time. All of the EORs that we've worked with have had to validate our engineering because obviously they're responsible, both of those folks are responsible for the final outcome. And so we've had a lot of validation of our engineering. But to more specifically answer the question, we meet all of AISC version 14 requirements.
Thank you, Henry. Next question that just came in is, what detailing software will Qnect interface with?
Well, thanks. At this time, we work with Tekla and Tekla only. Our system is built for future expansion into other potentially systems, but we're a Tekla service at this time, the Tekla interface app.
Thank you. And these are the questions that were asked. Unless someone has a question to put through right now, thank you very much for the webinar, Henry and Christian, and we thank you very much for your attending.